parts. So this one is kind of typically regarded as like um, the trickiest part of integration. Um, so yeah, it takes a lot of practice to kind of get used to integration by parts and get used to using it in a more efficient way, because a lot of the time, once you do learn integration by parts, or at least for me it was this way, when you get to a complex integral, you'll kind of look at it straight away and be like, I don't know what to do with that. It's probably integration by parts. A lot of the time it is, but you do actually need to learn the nuances of integration by parts, because sometimes you look at a complex question, you think it's integration by parts, and it actually isn't. And then you kind of go barking up the tree for a long while. So we're going to go over what it is, when to use it, how to kind of tell when to use it, and also like some complex situations in which you can use it, and also some tips for like questions in general. Okay, the formula for integration by parts is on your formula sheet. It isn't written like this, I don't believe. It is written in like a more complex format, but this is how I choose to write it because it's like more easily understandable. Um, and you're going to use it when you have the product of two functions, and the derivative of one would cancel the bad part of the integral of the other, right? So in this case here, we have two functions, and as we'll go through in a second, the bad part of one of these will cancel the integral of the other. And what I mean by that is that if you integrate one of these functions, it's going to cancel um, the other part that you don't want an integral, because up here, of course, we're going to integrate, right? And we'll get into this in a second. But the steps are, firstly, to assign each function as u or v, and then to derive u and integrate v, and then apply the formula. So what we have here is, in our formula, we have the integral of u and v dash. So what we're kind of saying is that in our integral, one of the functions is going to be u, and one of them is going to be v dash. And then in our formula, we need v, so we need to integrate this v dash to get to v, and we need to derive u to apply u dash in our formula here. So what we want to do is we want to select u and v, which one we pick is u and v, strategically, so that we can cancel some things out and make things a little bit easier for ourselves. Now, there are a few different kind of tips and tricks for integration by parts, or like kind of a few different things to remember that will help you to apply the rule. The first thing that is kind of usually taught to begin with integration by parts, is if you have a product where one of the terms is a polynomial and one of the terms is like some other function, what you can do is you can apply integration by parts so that u is the polynomial, because as you keep applying the formula, because you keep deriving the polynomial, it will reduce in power. We'll go over an example of this in a second to better understand it. But yeah, a simple rule is if you have a product of a polynomial and some other function, typically you let u equal the polynomial and then apply integration by parts multiple times until the polynomial kind of differentiates down. So there are a few other tips which I believe are on in a few slides time. So we'll go over them then, so you guys have like them in writing. But yeah, that's like the most typical one. The other thing as well to take note of is with integration by parts, like have a look at, if you're doing an exam, have a look at how many marks the question is worth. So if you have a lower mark question, um, you wouldn't be expected to integrate one part being v if it's too difficult, and if that's the case, then if it's a lower mark question, then probably don't do it. So what I'm talking about is a perfect example of this is if you had x ln x, right? This is a more complex example, but say you're picking which function is going to be u and which one is going to be v. Straight off the bat, if this was only worth like 4 marks, you know it's probably going to be like a little bit of an easy way out, right? It's not going to be like a massive question. So because of that, it's unlikely that the thing you want to be v is going to be ln x, because we don't have a formula for integrating ln x. So that means you have to do some other form of integration, some other method that we've learned to integrate this as a subsection of already doing integration by parts. And because of that, it's unlikely that this is going to be the thing that you have to integrate. However, if you get to like an 8-mark question, throw that assumption out the window. All I'm saying is if you have like a low mark question, it's usually going to be like the easiest option available to you. Don't try to overcomplicate it. And that really helps when you're choosing which part is u and which part is v. Kind of think, if it's a low mark question, which one is going to be easier for me to do? Not always, but as a general rule. Okay, let's get into an example of integration by parts. And after that, I think we actually have like 2 or 3 slides of my tips for complex questions on integration by parts. So this example here is pretty simple. The first thing that we need to do is, as I said, we need to choose which method of integration to use. Of course, we already know that this is in the integration by parts section, but you know, if you just came across this question in the exam, how would you know that we need to do integration by parts? The first thing that you could recognize is firstly that the two parts of our function, the derivative of one isn't going to cancel the other because the derivative of x is 1, so it's not going to cancel any other x. We can't really use trig identities because we already have a product of x and cos. So even if we substitute something in here for cos, we're still going to be left with like, you know, something in terms of like sine squared, blah, 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 blah. We're going to have some other trig function in here, and so we're still going to have a product of x and a trig function. So that's not really viable either. In this situation, we've kind of ruled everything out, except for integration by parts. So how do we know that we should use integration by parts? What we need to recognize is that the derivative of 1 or the integral of 1, and by 1 I mean like one of the functions. So the integral of one of the functions or the derivative of one of the functions is going to make things easier for us, because you remember our formula is uv dash equals uv, take the integral of u dash v. So we know that the derivative or the integral of one of these is going to make things easier for us. For whatever reason, the product of the integral of one and the derivative of the other is going to give us like an easy integral that we can actually find. So, what I recognize here is that the derivative of x is 1, and the derivative of cos x is negative sine x. The integral of cos x is sine x, and the integral of x is half x squared. So what's going to make it simpler for us is if we let u equal x and v dash equal cos x, because then in this section of our formula here, we're going to have u dash, which is going to be 1, multiplied by v, which is going to be the integral of cos x, which is going to be sine x. And that we can integrate. So this is a classic example of when we have a polynomial multiplied by another function. Here our x is our polynomial and our other function is cos x. So what we can do is if we let u equal our polynomial, it's going to like derive down, and then in our actual integral, we have a much easier time. So let's get on to actually applying this formula. Our integral is going to be equal to u multiplied by v, which is x sine x. Take away the derivative of u dash v. So u dash is 1 and v is sine x. So this leaves us with x sine x. The the integral of sine x is negative cos x. So this is going to be our integral here. Okay, awesome. So this was a simple example of integration by parts. Again, just to recap, how to know that you need to use integration by parts? You need to see if the derivative of one part of the function and the integral of the other part of the function would multiply together to give you something that you can integrate. Whether it does that by cancelling something out, or maybe the polynomial goes down, or something like that. There are a few other special scenarios, but as a general rule, that's what you need to know. Okay, now we're going to get into the tips for complex questions, and there are a lot because integration by parts can get really complex. If you're new to integration by parts and your brain is already kind of hurting at this point, that is okay. Maybe just like save the slides or take like a screen snip or copy paste or something like that. Pop these in your notes for later. But if you have already gone through integration by parts or you're pretty comfortable with it already, these tips will definitely be helpful for you when you are going through complex questions. Another thing that I recommend is if you are more of a high achieving student, something that you can really do to elevate your marks is when you're going through the complex questions that you're practicing, make sure that you're writing down the strategies for doing those complex questions, because sure, it absolutely is useful to just do them and get an intuition. In fact, that's the main part of it. But when you have like a whole year's worth of content to remember for your external, it really is helpful if you just have like a document of all of the tips for complex questions for like specific areas such as integration by parts, to just have a quick read through of like the days before your exam. Okay, so the general tips that I have for integration by parts. The first one, and this is kind of the more widespread one, is that you may need to use integration by parts multiple times. And this is where what happens is you're applying your formula and you get either your integral is like equal to like, something plus the integral of like something else, right? Maybe you have like a and the integral of b. So we just applied our formula, we've put everything in, but we still can't integrate this part here. It's better than it was before, but we still can't integrate this part. What we need to do then is apply integration by parts to this integral here. And this is where the integration by parts can get like really complicated. And it's like kind of, you start integrating something and then you think you're going really well and then you finish it and then you realize you need to integrate by parts again and then you finish it and then you realize you need to integrate by parts again and it's like, but, that is kind of the struggle with integration by parts. So an example of this is if you are asked to find the integral of the product of x squared and cos x with respect to x. If you let u equal x squared, which would be a good idea, right? Because the u is the polynomial. So if we do integration by parts enough times, it's just going to derive down to be left with, a constant number. You would still be left with trying to figure out the integral of 2x cos x. And from here, you would need to let u equal 2x and integrate by parts again. Because after this point, you would then be left with your derivative being a constant number, which means you're not going to have the product of two functions in the integral. And then again, this tip here is to make u the polynomial part, because then u dash is constant if you, it says integrate, but it should be derive, if you derive it enough. Meaning that eventually there's only one other function in the integral part of the formula. The other thing is if you make u the function to a power, it will eventually just derive down to just the function to the power 1. So if you have, say, sine squared x, if you let u equal sine squared x and you do integration by parts, you will eventually be left with a function with only the power 1, which often is much easier to integrate because then you don't have that power. If it doesn't make sense for a question to expect you to integrate something, like perhaps integrating ln x, this isn't a perfect example because in some cases with integration by parts we do integrate ln x. It depends, as I said before, on how many marks the question is worth. If it's a big mark question, then you might be expected to do that, but if it's not, then it's probably something simpler. But if it doesn't make sense, then that's probably u, and the other term is dv dx, or v dash. Okay, the other tip that I have is if you have integrals where you have a trig function multiplied by another function, such as like a polynomial, an exponential, whatever. You can keep integrating by parts until you get two terms with the integral that you wanted. Then you can collect them as like terms and simplify. This is kind of like, if you ever like do this yourself, or if you've done this kind of question before I explained this part to you, it's kind of like the biggest like aha moment ever when you're doing an integral and you're like, whoa, I can just use them as like terms, like I don't even have to do the integral. It's so exciting. But an example of this is what we have here, where we have the integral of e dx and cos of 2x. So typically, you wouldn't let u equal e to the x. Or you wouldn't even really do much with the e to the x because the integral and derivative are just like always going to be the same. It doesn't really help much, right? So even though this doesn't get rid of the e to the x in an integral, cos and sine cycle around when deriving, so you can just collect terms. So, applying this down here, the integral of e to the x cos 2x, what we have up here, if we let u equal e to the x, we are going to have u, which is e to the x, multiplied by v, take u dash v, and then by integrating this second term here, we're going to have a product of e to the x and cos 2x again. So even though we don't know how to integrate this, we're kind of like, we've got exactly what we started with, but what we can do is take this over here and add them as like terms. And then on the left-hand side, we're going to be left with the integral of e to the x cos 2x, which is what we wanted to find. And on the right-hand side, we're going to have an answer. So it just seems like one of those things where like you kind of feel like you shouldn't be doing it, or it shouldn't work, but it does, and you can do it. So, I mean, breaking the rules, I guess. So yeah, that's just like another interesting and kind of fun and cool tip that you can do, is you can collect the like terms if you find that you actually just can't integrate this certain part and it just kind of keeps coming around. Okay. So in this section here, we need to solve the integral of ln x. This is a pretty standard complex question, or something that maybe your teacher will give you in class as kind of like oh, try this, you won't be able to do it. But once you know the trick, it's actually very easy. And of course we have this Star Wars meme, when you integrate by parts, but the resulting integral has to be done by parts again. That's actually very frustrating. You've become the very thing you swore to destroy. Very accurate. So, for integrating ln x by parts, what you actually need to do, and if you don't want to know the answer yet, pause the recording, have a guess, but I'll tell you guys the answer now. What you actually need to do is you need to let u and v dash equal certain things. So we have a product here. Well, not necessarily a product, because a product is two functions. But we have like a multiplication here, right? So we know that one of them is ln x, and the other one is 1. Because this is technically like 1 times ln x. So if we derive ln x, we're going to get 1 on x. If we integrate 1, we're going to get x. But now we can apply our formula. So we're going to apply our formula. So for integration by parts, we're going to have uv, so x ln x uv, minus the integral of v times u dash. Of course, this is just going to cancel to 1, right? So we now have x ln x, take the integral of 1 with respect to x, which just gives us x ln x, take x plus c. So this is our integral of ln x. Now again, this is kind of like a trick question, so to speak. Once you understand the trick, it's actually really easy to do, but it is useful to know it in case you come across it in a question. Especially if your teacher hasn't taught you it in class. it might be likely that they'll kind of think that this is like unfamiliar to you. So it's like a trick to know. We do have this extra example here. I will leave it for you guys to maybe have a go at yourself. Pause the recording, do it for yourself, just because we only have a little bit of time left and we still have a lot of content to get through, unfortunately. But yeah, by all means, pause the recording, have a go at it yourself. When you're doing this one, remember when you have a polynomial multiplied by another function, what you need to do in that case using integration by parts as a hint. Okay.